Alright, hello everyone. If you watched my previous video, then welcome back. If this is the first video, then awesome. We are going to be going through the notes that hopefully should look something like this. Okay, this is the second page of the notes. We have 3 graphs down here and then kind of some general observations in the top. We actually are going to do these 3 graphs before we do our general observations. Okay, these are kind of the rules for what we're doing for all of these different things. So, with that in mind, let's head off and start with question number 4. Okay, if we were to expand this out, double distribute, FOIL, whatever you want to call it, okay, that is going to get us into our expanded form. So if we take x times x, that is x squared. If we take x times 2, that's plus 2x. And then negative 1 times x is minus 1x. Negative 1 times 2 is minus 2. Okay, so all I did was FOIL this, okay? I got to this right here. Can we combine like terms? You betcha. So I'm going to take my 2x and subtract 1x. So that'll leave x squared from up here plus 1x and then minus 2. And so this actually right here is the expanded form. And this helps me know what my parent function should be. Because looking at our parent function, all we have to do is look at this first term. Okay, it's going to behave generally like this. Okay, so our parent function is y equals x squared. Our degree is going to be 2 because that's the exponent that goes with that. The maximum number of turning points is going to be 1 less than the degree, so 1. Our end behavior, okay, we have to look at the degree and we have to look at the sign in the front. So we have a positive sign here, which we don't really put, it's implied, and our degree is even. So we're going to be going the same way, and we're going to be going up on the left-hand side and on the right-hand side. Now, our real zeros is what's interesting about 4, 5, and 6. Our real zeros come from each factor and setting that equal to 0. Okay? So if we set this x minus 1 equal to 0, we will get a real 0. And if we set x plus 2 equal to 0, we will get a real 0. Okay? It just so happens that x equals 1, because 1 minus 1 is 0, and then x equals negative 2, because negative 2 plus 2 is 0. So these are my real zeros. X equals 1, and x equals negative 2. Now, both of these actually have a multiplicity. Okay? Every 0 will have a multiplicity. Now, up here, do we have an exponent? We don't really, but if you want to put a 1 in here, you can always put 1 as an exponent. It doesn't change anything. Okay? So the multiplicity is the exponent that goes with this factor. So 1 has a multiplicity, and I'm going to abbreviate multiplicity of 1. Okay? And so our graph is going to cross because that multiplicity is odd. So our graph crosses the x-axis. Okay? So that takes care of one of these zeros. Now we have one more. Okay? That's negative 2. So negative 2 has a multiplicity of, let's look up here at our exponent. Well, it's 1 as well. Okay? So negative 2 has a multiplicity of 1. So the graph will cross the x-axis as well. So hopefully you can see that all the way down there. And that is the multiplicities for both of these real zeros. Okay? So for some of these polynomials, we're going to get a lot of real zeros, and we're going to have a lot of multiplicities. The interesting thing, though, about multiplicities is that if you look at these numbers, okay, a multiplicity of 1 and a multiplicity of 1, these should add up to the degree, okay? So that's a great way that you can check to make sure that you're doing all of this right. 1 has a multiplicity of 1, negative 2 has a multiplicity of 1, 1 plus 1 is 2, so we know, hey, we're pretty good on this. Now, to sketch a quick graph, okay, we have to know what the real zeros are. So at 1, okay, that's going to be an important point, and at negative 2, that is going to be an important point. So we know that at each of these points our graph will cross the x-axis. Now we look at the end behavior, because on the right we're going up and on the left we're going up. So over here we'll be going up, and over here we will be going up. So the only way to get our graph to cross through these 2 points is to go like this and go below. Then we're going to turn and go up, and we're going through both of these zeros. Okay, so it satisfies our multiplicities and it also satisfies our end behavior. Our maximum number of turning points was 1, and we turn once, right about here. So if all those things work out, then we know that we did the problem correctly. And I forgot to mention with question number 4 is you don't have to write all this stuff down, but it's probably not a bad idea. It certainly helps you practice all this stuff, because it is important to know these different things, because it helps you sketch the graph. Okay. For question number 5, we have 3 different factors here: x plus 1, x minus 1, and x minus 2. Okay, if we were to factor this whole thing out, alright, much like what we did with number 4, okay, our parent function is going to come out to be y equals x to the third, because x times x times x is going to get us our highest powered thing, and so that is going to be x to the third power. Our degree is 3. Our maximum number of turning points is 1 less than that, so 2. So we can change direction at most twice. The end behavior depends on our degree and the sign. So we have an odd degree and positive, so we know that on the left we will go down, and on the right we will go up. Our real zeros come from these factors. Okay, so if we set x plus 1 equal to 0, x plus 1, and we solve for that, we know x will equal negative 1. If we set the second factor equal to 0, so x minus 1, okay, we know that if we add 1 to both sides, x will equal 1. If we set that third factor equal to 0, so x minus 2, add 2 to both sides, x equals 2. Okay, 2 minus 2 is 0, 1 minus 1 is 0, negative 1 plus 1 is 0. So our real zeros here, we have 3 of them. Okay, this guy, and this guy. So that's what we write here in our real zeros box. X equals negative 1, x equals 1, and x equals 2. Alright, so not that bad. The multiplicities are just the exponents that go with those. So again, if we don't have an exponent, we can write a 1 there, okay? It's implied that it's the first power. So hopefully we can fit this in our multiplicities box, but negative 1 has a multiplicity, okay? That's what MULT period stands for. Multiplicity of 1. Okay, that's the exponent that goes with that factor. So our graph will cross the x-axis. And that's because 1 is an odd number. Okay? So let's do our next one, which is x equals 1. So 1 has a multiplicity of, we look up here at our exponent for this factor, and it has a multiplicity of 1, because that's our exponent. So our graph will cross the x-axis. And the very last one. Okay, so just splitting up my different real zeros and my different multiplicities. My last 0 is x equals 2. So 2 has a multiplicity, and then we look up here at our exponents, a multiplicity of 1. So our graph is going to cross the x-axis. X-axis. And if you can fit that in your box, or just off to the side, because I guess you don't have a box, that gives us all the information we know to quickly sketch this polynomial. Okay? So the important things to know and to put points at is here at x equals negative 1, here at x equals 1, and here at x equals 2. So that's going to be here at x equals -1, x equals 1, and x equals 2. We know that we are crossing at each of these places, and we know on the right-hand side we're going up, and on the left-hand side we are going down. Okay, so those are all important things to know. Now, we could have a maximum number of 2 turning points. We'll see if we have that. So we're crossing here, so we have to come from this direction. We're going to cross. We know we have to cross here too. Okay, so we're going to have to turn around and cross through that point, and we know we have to cross here. So we will also have to turn around and cross through this point and head up towards that arrow so that our end behaviors match up. The number of turning points we have also matches up because we could turn 2 times, and we do turn 2 times, crossing at each of these zeros. Okay, so these things are what we're looking for, and they make graphing this or sketching a graph really easy if we know how to get our zeros and how to get our multiplicities. Alright, for question number 6, you may be saying, well, Mr. Johnson, what do we do if we have this -2 here? Because the adding things on the end, that ruined our party, you know. We couldn't do all this fun stuff with multiplicities and zeros. And all I have to say to that is, well, it doesn't matter if we're multiplying a factor, okay? That doesn't really change anything. It changes things if we are adding here on the end. So adding on the end kind of ruins our party, ruins all our fun. Now, when we expand this out, we can have a parent function of y equals x to the 5th power. Okay? The degree that goes with that is 5. The maximum number of turning points is 4. Our end behavior depends on our degree and depends on our sign. So we have an odd degree and a negative sign here. So on the left it could go up, and on the right it will go down, just like that. Okay? The opposite of what it normally would do. That's from the negative sign. Our real zeros come from setting this equal to 0. So we say 0 equals x plus 2, and so subtracting 2 from both sides, we get x equals -2. And that is our real 0. X equals -2. Okay, for multiplicities, we have to look at the exponent that goes with that factor. Okay, so this factor here has an exponent of 5. So -2, okay, which comes from that, has a multiplicity of 5. Okay, and since that is odd, our graph crosses the x-axis. Okay, and unfortunately we didn't have any examples, at least not yet, of things with even multiplicities, but hopefully we will see some of those soon. Okay, so sketching our graph based on all of this information is pretty easy. Okay, first thing that we look at is our zeros. So here at x equals -2, that's going to be an important point. Okay, so put a dot there at x equals -2. And then we have to look at our end behavior. To the left we are going up, and to the right we are going down. Okay, and these kind of could change depending on what happens. And we could have a maximum number of 4 turning points. Okay, and let's look at what our graph does. Our graph crosses here. So we need to know that it acts like y equals x to the 5th. We're going to come down here. We're going to go and cross through this point and then head down to this arrow. So it should hopefully look something like this. And it's always good to check. Okay, we can always plug that into a calculator, a graphing calculator, and check that. But that's an easy way to quickly sketch and show that, hey, our graph looks like that. Our 0 is here at x equals -2. Okay, the very last thing that we want to do is make some general observations. So these are kind of the rules for that table and rules for things that we should look for when we're dealing with polynomials. Our parent function, okay, comes from the expanded form. Okay. And actually it comes from that first term, okay? and the first term is going to be the thing with the biggest exponent. So when we do all the math and expand it, the thing with the biggest exponent is going to be our parent function. And our polynomial will behave like our parent function. Hopefully we have good parents. The degree is going to come from that parent function, okay? So it is the exponent of the parent function. And FTN, period, stands for function, okay? The maximum number of turning points is the degree minus 1, okay? Our end behavior depends on the degree and the sign out in front. So if you have a caution sign out in front, that's going to be a different behavior than if you have a stop sign out in front. Maybe like a beware of dog sign. For our real zeros, okay, this occurs from factored form, okay. So it comes from our factored form, and our factored form is just when we have, if you guys can see it here, if we have factors here, okay, if it's listed as factors. It's not in factored form if we're adding things on the end, okay, so we have to remember that. So our real zeros come from the factored form, and setting factors equal to 0. Okay, so that's where our real zeros come from. And we have to solve them once we set them equal to 0. So setting factors equal to 0 and solving them. Multiplicities are the exponents that go with the zeros or the factors. Okay, and then you have this kind of sub box here, and I'll draw it in because I forgot to here on this paper. Okay, and it talks about our multiplicities, and it talks about our graph, okay? So we have multiplicities and we have graph. If our multiplicity is even, okay, our graph is actually going to just touch the x-axis. Okay? And an example that we've seen already is y equals x squared. Okay? That's really like x plus 0, that quantity squared. And so we know that it could touch the x-axis. It could just hit the x-axis and bounce off and go to the top. Or if it's reflected, it could go down. So that's an example. Y equals x to the 4th. We did that one a couple days ago. So those are some even multiplicities, and we know that it could touch, and it will touch, the x-axis. If we have an odd multiplicity, okay, our graph will cross the x-axis. And these two things will always happen if it is in factored form. Okay? If it is in factored form. So, with that, hopefully you'll have enough information to finish any homework, and on the homework you actually have to make your own polynomial, so try some goofy things. You know, you get some pretty cool graphs if you're just willing to explore. And hopefully we can come back tomorrow and we didn't screw you up too bad with this video. So, thank you very much, guys. We'll see you tomorrow.